Hi dear students, so today we have again come with a new video of class 9, that is Newton's third law of motion. In between the laws we have read three laws, first law, second law, and this is the last, third. This is the most easiest statement and it seems to be the most toughest concept whatever the three laws we have read. Okay, so in the first law we have learned about force. Okay, so we can able to define it, that is we have learned about the definition of force in first law. In second law we have learned the measurement, that how we can able to measure the force, that is the second law. Now the third thing which is left, that is what will be the effect when the force is applied of the body. When a force is applied on a body, what effect is shown? So in third law we have to learn effect of force on a body. Now coming to the statement, what statement is given by scientist Newton? What is the statement is, we all know the statement by the way, to every action there is equal and opposite reaction. So one thing I'll make you clear here, action and reaction both are talking about force. We can say when we apply a force on a body, that body also giving a opposite force on us. That is only the effect of force on a body. Very simple thing. Assume one object is kept here. Okay, I want to pull it. So follow the concept, don't follow the drawing. Okay, so I just want to pull it. So when I am applying a force on it, okay, that force is known as action, and due to that action this body will give a force on me, and that is known as reaction. Okay, so this is the effect of force on a body. How the action will act, how the reaction will get, that we have to discuss step by step. So simple thing, when we are talking about effect of force on a body, then we have to follow the statement of Newton's third law of motion, that to every action there is equal and opposite reaction. That means how much action, how much force you have applied on that body, same amount of force is applied by the body to you. Okay, and that force is taken as reaction, and that should be in opposite direction. Okay, now from here if I want to show you one very easy concept, assume two balls, okay, moving in one direction. Okay, two balls are moving in one direction. Assume it is ball A, it is ball B. So the speed of ball A, that is VA, and the speed of ball B, it is VB. If VA is greater than VB, that means the speed of ball A is greater than the speed of ball B, then what will happen? After some time there will be collision. Okay, so collision means the A ball will apply a force on B. Okay, so as A is coming forward, so this A ball will apply a force on B. if that force we have taken, I'm just erasing this diagram, then it will be easier for you to understand. So first thing we have written, force on B by A. Okay, force on B, this is B and this is A. How much? That should be taken as FBA. FBA means force on B due to A. Okay, force on B by A, and that is your action. And for that reason, B will apply a force on A. That should be a reaction. Okay, and that is FAB, and that is known as reactional force. Okay, in this case, as per the statement, that is, to every action there is equal and opposite reaction. So this FBA must be equal with FAB. That means action will be equal to reaction but opposite. So here is a minus sign. So we can say this is a representation of Newton's third law, that is FBA equals to minus of FAB, right? To every action there is equal and opposite reaction. Now I am giving you a very interesting thing. Okay, what is that? As we have told, the two forces will be equal and opposite. Then what thing can be happened here? Assume if I am talking about an object, here I am applying a force F, and from opposite direction here I have applied another force F. Both the forces are F, both are equal, and they are acting in opposite direction. So if same forces, same amount of forces acting oppositely on a body, then the net displacement will be 0. Because you see, if same amount of force is applied on a body, then there will be not a displacement. The displacement will be 0, and this condition is known as balanced force. Then one thing is come to our mind, that if equal and opposite forces are applied, then how a body is displaced? How a body will displace? Because we have seen that when two equal forces are applied, equal and opposite forces are applied on a body, then the body should be static. Simple thing. If this is a pen, I am applying two equal and opposite force. From this pump, I am applying force here. From this pump, I am applying force in this direction. If two equal force is applied on this pen, you see the net displacement gonna be 0. So it is a balanced force condition. So if Newton's law is correct, then no body will displace, because if you apply a force on it, opposite force will be applied, and these two are equal, then no displacement occur. Right? Yes or no? No, it's not right. Fine. Whatever the things I have explained here, whenever I have told the same thing, I have deliberately changed one thing. What is that? Whenever we are discussing about this story, you see here two bodies are there. One body will apply a force on another body, that is FBA. FBA is applying on B, right? Applying on B. FAB whenever the reaction force is acting, that is applying on A. So here, whatever we are talking about balanced force condition, it is happened only when these two forces are applying on a same body. But here you see, the action and reaction never acts on a same body. That conclusion we have to make. Otherwise, this problem, it will arise in our mind that if the forces are equal and opposite, then why the displacement occurred? Simple thing, action and reaction never acts on a same body. Okay, example, it's a very easy example we have to discuss about. Assume I'm throwing a ball to the wall. So sometime we are practicing the catch. So assume this is a wall. I have thrown, so assume this is my hand, whatever the hand it may be a hand of a ghost or hand of Thanos, whatever. I have thrown the ball here, and after reflecting, the ball again comes to my hand. Simple catch. I have thrown to the wall, and after that I catch the ball. So where the action and reaction is applying. So whenever I have thrown the ball, by the ball I am applying force on wall. So we can write here, by ball the force of action acting on wall. Okay, and by that, whenever you are applying a force on wall, the wall will give a reaction. So reaction is given by wall on ball, and that's why the ball returns back. So action, if we are talking about where the action is acting, the action is acting on wall. Where the reaction is acting on ball. And that's why we can able to do any work. There will be not a problem of this balanced force condition, because the balanced force condition will occur in that place when it will apply on same body. But here you see, action and reaction never acts on a same body. So there is the chance of balanced force condition, it is not possible. Okay, I'm telling you one more thing. I'm giving you some examples of action and reaction. So I'm removing this thing. If you want to copy it, pause the video and copy it. Okay. So you have to remember one thing, action and reaction never acts on a same body. Now first I'm talking about examples. Book on a table. Number one, first example. So if assume you are having a table, okay, and you have kept a book over here. Okay, so as you have kept a book over here, the book will apply a force downward, that is its weight, and due to that one reaction will be applied on the book, that is by table. So action, here you see, this weight is applied on whom? On table. And the reaction, it is given by table to book. Okay, so here also you see, action and reaction never acts on a same body, and in this case the book is remains static on the table because the reactional force will be equal to the weight of the body. Whenever we are talking about the contact and non-contact force, in contact force one force we have taken, that is reactional force. That whenever, assume I have hold the pen on my pump, that means the pen is applying a weight in downward direction on the pump, and the pump will giving a reactional force to the pen in upward direction. Both are equal, that's why the pen is static. Otherwise, it can move upward. Okay, so this is the first example. Number two, the movement of a human being on a floor on a road. How it is possible? When a man walks or when a man run over a road, how it is possible? So here it's a very simple thing. I just want to show you. Okay. So assume like is there. Whenever we just walk, okay, just feel it. Assume this is a flow. Okay. If you feel it at the time of walking that we are applying a force downward at ground. At ground, we are applying a force F. And due to that, the ground giving a reactional force to you. So reactional force by ground. Okay, and that should be same, and by that reaction you just move in forward direction. You see, whenever we run, that time the force we apply on the ground, that is more. Okay, and that's why the reactional force will be more, and that's why we can able to run. Here also you see the force is applied on ground, that is the action, and the reaction you have got on body. Okay, so reaction is applied on your body. So here also the same thing is there, that action and reaction never acts on a same body. Okay, how we can able to measure that action and reaction are same? So for that we have done a very easy experiment. It's a very easy experiment, and that is shown in your book also several times. So assume here it's a wall. So in wall, one fixed point is there, and in fixed point what we have attached? We have attached one spring balance. Okay, maybe the drawing is, I just want to do it a little faster. Okay, and here you see the scaling is there. Okay, so assume it is, here it is 2 4 6 8 10. Okay, so this is the scaling, and along with that we have connect another spring balance. Okay, spring balance, you know, it's an instrument which is used to measure the weight of the body. Okay, and here also you see, here the scaling 2 4 6 8 10, and at extreme point assume it is pulled by you. So the condition of the finger is very bad. Whatever, I'm just trying to do it faster. Okay, so see, two spring balances are connected in opposite direction. Here it is starting from here, it is the starting point, that is 0, and here is the starting point, here it is 0. When you are applying force on it, okay, so then assume the pointer comes here at 6. Okay, that means you can assume that here you have applied a force of 6 Newton. In that one you have not applied anything, any force, but you will see here also a reading that is also 6 Newton. Why? Simple thing is that you are applying action on this spring balance, and due to that one reactional force is applied by it. Then how? See, these are the connector. As you are applying action towards you, So that value of action is shown in this spring balance. And as it is connected with the wall, okay, so this wall will give a reaction to you. So you are applying action on wall by this connector, and the reaction is shown by the wall to you, and that is measured by this spring balance. And here we have seen the two value of action and reaction are same, that is 6 Newton. So by this experiment also we can say that what Newton has told, that is completely correct, that to every action there is equal and opposite reaction. Okay. So apart from this also many more examples are there. Whenever the boats we all know, whenever the boats are floating over the river, okay, with the help of oar, we all know that here man who's sitting by holding the oar, and by that he can able to take the boat in any direction. How it is possible? Now assume if the action with the help of oar it is done by this direction, then the reaction is applied by water to the boat. You are applying force, that is you are doing an action on river, so action on river and reaction on boat. And that's why you have seen also in many more videos that, or you have, if you see it on boat you can able to understand that he is applying force in backward direction and the boat is moving forward. Okay, so very simple thing, and by that only we can say that action and reaction are equal and opposite. And here also action is applying on river and reaction we have seen on boat. So here also it is not applied on same body. Apart from this also many more examples. If I'm talking about the gun, okay, if you fire a bullet, okay, so it is very difficult for me to draw a gun. So just like assume, so mostly the PUBG players can draw the gun very well, better than me. Okay, because they are always thinking about what gun they have to take. Okay, so I don't know what type of gun it is. It is the West gun among the. Okay, so assume whenever you have fired a bullet, that means the gun is giving a force on the bullet, that is force of action on bullet, and for that you will get a reaction. So when the firing is occurred, you will feel that the reaction is applied on the gun and it is coming backward. Have you, I think many of you have played with that gun, air gun. It is kept mainly in the fairs, okay, that to hit the balloon, okay, and burst the balloon. In that case, whenever you have fire, you will feel the gun is just coming backward and giving a blow at your shoulder. Okay, so that is the reaction given by bullet on gun. So that is also an example. Action is acting on bullet, reaction is acting on gun. Not only that, if I am talking about the rockets, okay, Mission Mangal, no, apart from this also many more things are there. So when the rocket goes upward, it has given an action on ground, and due to that the reaction is given on the rocket, and by that reaction it moves up. You have seen also whenever the rocket is being launched, that time a huge amount of fire we have seen beneath the rocket. That means the force is applied on the ground, so that the reactional force is coming to the rocket, so that the rocket can move upward. So very simple thing. So these are little bit of examples we have discussed. Okay, simple thing. More examples are there, that whenever you have jump on the shore, okay, when you have jump on the shore from the boat, okay, simple. Assume you have reached on the shore, you want to jump from the boat, then what you have done, you are applying force on the boat, and by that you will get a reaction by which you are jumping on the shore, and the boat is moving little backward because you are giving an action on boat, and the reaction on you, that's you why you are coming outside. So many more examples if I'm talking about the simple experiments of Newton's third law of motion, that is everywhere around ourselves. Whatever we have seen, you feel, you see, you also understand how the force of action and reaction is acting on it. Now the next thing, in your book, if I'm talking about, up to this it is left, but I will make you learn little more than this. Why? Because if I stop here, whatever your book has done, then your knowledge shouldn't be completed. What do we know from this Newton's third law of motion, that we have to understand? What conclusion we will get? Otherwise, we cannot able to say more on that. The examples, it is okay, but some mathematical expression also we have to learn. What is this? That is a special combination of Newton's third law and Newton's second law. Let's see. So here we just want to show you the effect, or effect is not appropriate word, conclusion from third law. Assume the same experiment I have shown you earlier, that it is a ball A, it is a ball B. Assume it is moving with a velocity of UA, and ball B, it is moving with a velocity of UB. So as we are talking about initial velocities, so that's why we are taking UA and UB. So if I'm telling here, if UA is greater than UB, okay, so A will collide with B. Very simple thing. So after some distance, A is collide with B. Okay, so this is a body A and this is a body B, and this collision occurred for t second. Okay, this collision occurred for t second, and after that they are moving with different velocity. This is A and this is B. That time their velocities are changed. The velocity of A is VA and the velocity of B is VB. So you can assume that for the pokers, whenever it is played, that time, okay, the billiard, forget about pokers, billiard. So one billiard ball is collide with the another, and after that they are moving with different velocity. And one thing we have to mention, that no external force is applied on it. That means, so you might be asking, sir, if no external force is applied, how this body is moving with a velocity? Simple thing is that the force is not responsible for the collision. They are moving together with different velocities, but I am not applying extra force to collide. They have collided by their own. Okay, maybe earlier I have given force, that is not acceptable. At the time of collision I have not given any extra force. Okay. So from this one, what we can understand, that A is applying a force on B and B will give a reaction. So first we have to see force applied by A on B, that is equals to FBA. So FBA, it represents force on B by A. Force on B by A. So how we can able to understand it? Assume the mass of the body A, it is MA, and mass of body B, it is MB. Okay, and here the mass should remain constant. One thing I am telling, that it is not in your syllabus, so if you are not feeling interest in this portion, whatever the thing we have discussed, you can stop the video here. Okay, because whatever the things we have already told, that is in your syllabus and that is completed. Here the extra thing I have told, it is needed. Okay, so force applied by A on B. So if I am talking about force on B, that should be mass of B into acceleration of B, mb into AB, because we know that force equals to mass into acceleration. Okay, so acceleration of B, what it will be? Simple thing, acceleration equals to VB minus UB by T. Okay, VB minus UB by T, that is the force applied by A on B. And now we are coming force of reaction on A by B. So definitely B will give a reaction to the body A, so that should be written as FAB. So FAB equals to, directly we can write MA into VA minus UA by T. So VA is the final velocity, UA is the initial velocity, VB is the final velocity of B, and UB is the initial velocity of B. Okay, so this is our calculation. And now from where here we can written as per, so this can be written by Newton's second law. And now as per Newton's third law, we have written that FBA, this is the action, that should be minus of FAB, because reaction is equal and opposite as per Newton's third law. So if this is correct, we will put the value, that is MB into VB minus UB by T should be equals to minus of MA VA minus UA by T. Okay, so here you see TT, it is common, cancel out and then multiply. So if you multiply here, it will come MB VB minus MB UB is equals to minus MA VA plus MA UA. If I just arrange it like this way, that this minus sign will be interchanged. Now you see what we are taking? We are taking MAVA in this side. So that is MBVB plus MAVA should be equal to MAUA plus MBUB. Now you see, I think it is little clear. Here you see MB into VB and MA into VA. What is it? These are the momentum. So MB into VB, that is the final momentum. MA into VA, that is the final momentum of A. MAUA, that is the initial momentum. So from this we can write that sum of final momentum is equals to sum of initial momentum. What is it? This is known as conservation of linear momentum. So that is a very good conclusion of Newton's third law of motion, that from Newton's third law of motion we can get conservation of momentum, which tells us that sum of the final momentums will be equal to sum of initial momentum. So that is the conclusion from the third law. This is not in your syllabus. If you are not interested, no need to see video from here. Okay. If you are getting little interest here, then I can show you that what can we get from this conservation of momentum. So first thing we will get that whatever we have told about the action and reaction, so by the concept of action and reaction, what extra thing we can get, so that one example I will give, that is recoiling velocity of gun. Recoiling velocity means, just now I have told now that whenever one bullet is fired from a gun, okay, so that time when the bullet is fired, so the action is done by the gun on the bullet and the reaction is given by the bullet to the gun. So here the recoiling velocity means how much the gun is coming backward. How much the gun is coming backward. That is the recoiling velocity. Earlier time, I'm giving you a very good example, that earlier time you have seen the guns, that time the guns are very much heavy. So what will happen, whenever the firing is occurred, sometimes the people often fallen down due to the recoiling velocity of the gun. So here, by the concept of conservation of linear momentum, I just want to find what will be the recoiling velocity. Let mass of gun is equals to m, mass of bullet is equals to small m. Initially, if you see, whenever no firing is occurred, whenever any bullet is fired, though initially both are static. So we can say the initial velocity of both the gun and the bullet is 0. Now finally bullet velocity when it is fired, assume it is small v, so this is the velocity of bullet, that is small v, and due to that you will get a blow in backward direction, and that blow is known as recoiling velocity. Means the velocity of the gun in backward direction, that is known as recoiling velocity. So recoiling velocity is capital M, capital V if we have taken. So here our elements are given. So as per conservation of momentum, we can write that initial momentum, sum of initial momentum equals to sum of final momentum. But you see, sum of initial momentum, that should be 0, because the velocity is 0 and the momentum is velocity into mass, or mass into velocity. So here if I am talking about momentum conservation, so it is 0. In bracket we can write that initial velocity are 0. So initial velocity of both the gun and the bullet, both are 0. So here it is 0. And sum of final momentum, capital M into capital V, that is the mass of gun and velocity of gun, plus mass of bullet, velocity of bullet. And from here we want to find out this recoiling velocity, that is V. So V equals to minus of mv by m. So from here we can able to understand that what will be the recoiling velocity of the gun, as well as you see the minus sign represents, this negative sign represents that it is acting opposite direction. So this is we can say the conclusion of Newton's third law, because if you have not learned about conservation of momentum, then your knowledge is not fulfilled from Newton's third law of motion, because the conclusion of Newton's third law is very important, that is sum of final momentums should be equals to sum of initial momentums when, here also one thing, when no external force is applied. Earlier I have written that no external force is applied, or otherwise I have written the statement here, conservation of linear momentum. It tells us when no external force is applied on a body, then sum of final momentums should be equal with sum of initial momentums. Okay, so that is the statement of conservation of linear momentum. If you are not interested in this, then forget. Okay, this is not in your syllabus. Thank you.